Okay, we're going to go for a quick, short lesson on simplifying radicals. This is from section 6.3. And let's first start with the word radical. What is a radical? It's a root, right? And what we should know is that a square root is really the power of 1/2, okay? There's technically an invisible 2 right here. Now, when we want to refer to something as the third root, then we would put a little 3 right there. And the third root is really the power of 1/3, okay? Likewise, the fourth root or fifth root or sixth root or whatever root you want, that will be the power of 1 over whatever that root is, in this case 5, okay? So when we think about this, like we all know that the square root of 9 is 3, but it could have been rewritten as parentheses to the power of 1/2, and we could actually simplify and get the answer 3 without really thinking of roots. You could think 9 is really 3 to the second power. So you could say that instead of 9, you have a 3 to the second power right there. And of course, a power to a power you multiply, and 2 times 1/2 is 1. So you really have 3 to the 1 power, which is really pointless to put a 1, so you would erase. Now I know you're thinking, why the heck would I change this square root to a power of 1/2 and then change the 9 to a 3 to the second power to be able to multiply exponents? The only reason I did that is because we're going to be simplifying different types of roots with this method of multiplying powers with powers, right? Power to a power you multiply. Again, if I told you what is the cube root of 8, we already know the answer is 2, because 8 is really 2 to the third power, right? And the power of 3 to the power of 1/3, multiply them, that would become 3 over 3, which is 1. So you end up with 2 over 1, which is just 2. And again, you're probably thinking, I am not going to do this, but you will, because when you have variables with powers, that's the only way to do it. But before continuing with different types of roots, let's take a look at a square root of a non-perfect square number. So right here we have the square root of a non-perfect square number, and we have the cube root of a non-perfect cube number. Remember, what is a perfect cube number? 1, because 1 times 1 times 1 is 1. 8, because 2 times 2 times 2 is 8. 27, because 3 times 3 times 3 is 27, okay? Let's go back to here. How would we do this square root of a non-perfect square number? Well, we want a perfect square number, so what we're going to do is we're going to rewrite 20 with multiplication as a perfect square number times a different number, okay? So what did I do here? I did not have a perfect square number. I rewrote it with multiplication to get a perfect square number, right? 2 times 5 doesn't cut it because 2 times 10 doesn't cut it because 2 is not a perfect square, 10 is not a perfect square. Right here, 4 times 5, yes, 4 is a perfect square number. That's what we want because we are actually able to do the square root of 4. And the rule of square roots says that if you have multiplication, you could split that root to each of the terms that you're multiplying by. So the square root of 4 is 2, and the square root of 5 will stay the square root of 5, okay? Now let's take a look at this one over here, the cube root of 16. Well, 16 is not a perfect cube number. I would like a perfect cube number. So a perfect cube number would be like the number 8. 2 times 2 times 2 is 8. So I'm going to rewrite it with multiplication, 8 times 2. And when I split the cube root of 8 is 2, and the cube root of 2 is still the cube root of 2. So there's your final simplified answer on that one. I would also like to compare a different type of square root with a different type of cube root. How about if I said, what is the square root of -9? You would say that the answer is 3i, okay? Because we all know that the negative sign in front of the square root comes out as an I, okay? Again, if you were to think of this logically, what number times itself will give you a -9? There is no real number times itself that'll give you a -9. 3 times 3 is +9, and even -3 times -3 is also +9. So that's why this minus sign comes out as an I, and the square root of 9 is 3. So 3i is your answer. Now compare that to, let's say, the cube root of negative 8. Some of you might think, oh, the answer is 2i. Wrong. Yeah, it's not 2i, because the answer is actually negative 2. I mean, think about it. What number times itself 3 times will give you this answer, negative 8? That's negative 2 times negative 2. That's positive 4 times another negative 2. That'll actually give you a negative 8. So heads up, guys. Square roots, you cannot have a negative on the inside. That'll produce an imaginary value. But on cube roots, yeah, you could have a negative on the inside. Your answer will be negative, right? All right, let's move on to actually some simplifying with variables. Let's begin with something short and sweet. The square root of x to the 16th power. Now, some of us might be thinking, oh, 16 is a perfect square number. The square root of 16 is 4, so the answer is x to the 4th. Wrong. Okay, it's not. Let's think about this. We know that the square root is really the power of 1/2. Which means that you have an x to the 16th to the power of 1/2. And we know that a power to a power you multiply, and 16 times half is 8. So the answer is x to the 8th, not x to the 4th. Another thing to recognize is that on square roots, you want a number, a power that's divisible by 2, right? Because the square root is a 1/2 power, which is like dividing by 2. Likewise, a cube root is, let's say, x to the 15th. You want something that's divisible by 3. So what's the answer to this one? It's going to be 1/3 power, x to the 15th, and of course a power to a power you multiply, and 15 times 1/3, it's like saying 15 divided by 3. The answer is x to the 5th. Okay, so that works out all beautifully. However, what if you had, let's say, x to the 17th instead of x to the 16th, right? So we have the square root of x to the 17th. So we know that a square root is really the power of 1/2, and we want this to be divisible by 2, but it's not. It's not divisible by 2. So what we're going to do is rewrite with multiplication to get a power that's divisible by 2. We all know that the square root of, we all know that x to the 17th could be rewritten as x to the 16th, which is a perfect, which is an even power, times 1 more x. I mean, this is this, right? X to the 16th times x really is x to the 17th. So I just rewrote it. This is still x to the 17th. I just rewrote it with multiplication to get what we wanted, an even power. And now we could split the root. And now you could think, okay, right here we have the power of 1/2, x to the 16th, power to a power multiply. Answer will be x to the 8th with the square root of x. Okay, now this square root of x you can't do, so you just bring it down. Let's try one with a perfect cube, not a perfect cube, a cube root. So like, let's say we have the cube root of, let's just say, x to the 8th power, right? Now this might be a little confusing because some people might be thinking, oh, that is a perfect cube number. I could do the cube root of 8. The answer is x squared. Wrong. Okay. On a cube root, we want a power that's divisible by 3 because we know that the third root is really the power of 1/3. So we want a power that's divisible by 3. So obviously you can't just magically add 1 more x and make that a 9. So we need to rewrite it with multiplication to get something that's x to a certain power that's divisible by 3. That would be x to the 6th times x squared, right? X to the 6th times x squared is x to the 8th. All I did was rewrote this to this with multiplication. That way I could split my third root to each of those. And of course, we now know that x to the 6th to the 1/3 power, power to a power multiply, 6 times 1/3 is like dividing 6 by 3. That'll be x squared. Now what about this guy? You can't do it, so just bring it down. The cube root of x squared. So your answer here is actually x squared, the cube root of x squared. All right, so let's jump into some more examples. So looking at this one right here, what we're going to do is do what we did back with square roots. We are going to take the terms that are being multiplied, the negative 64 times x squared times y to the 36, and we're going to split them up. So I will have the cube root of negative 64, the cube root of x squared, and the cube root of y to the 36. Now, some students might from the beginning look at this thing and make the mistake of thinking the square root of 64 is 8 with an I. That's wrong, right? Some people might make the mistake of thinking the square root of x squared is just x. That's wrong, right? Also, some students might just see 36 and think, oh, that's a perfect square number, so the answer is going to have a y to the 6th in it if I do the square root of 36. That's wrong also. Okay, you have to split them up like this to handle each one individually. So the question is, what number times itself 3 times will give you negative 64? And the answer is negative 4. Okay, that is the answer to this guy right here. Okay, let's move on to the next one. This one we cannot do. Now, let me show you why we cannot do it, because even if we were to write it as a rational exponent, what do I mean by that? Even if we were to write the third root as a power of 1/3 and put the x squared right there, I can't really divide 2 by 3, right? 2 times 1 is 2, 1 times 3 is 3, so 2 divided by 3 doesn't work. So I can't really do anything with this, so I'm just going to leave it like this, okay? How about that last one though? This last one right here, if I rewrite it as the power of 1/3 with the y to the 36 right in there, then 36 times 1/3, that's like saying 36 divided by 3, right? That's going to be, and I'm not sure if you guys really get this, but let me show my work here. 36 times 1/3, you're going to have to put the 36 over 1, and you can multiply the top with the top, that'll be 36, the bottom with the bottom, that'll be 3, and 36 divided by 3 is 12. So when I say 36 times 1/3, we're going to get 12. That is our answer, okay? So we have y to the 12th. Okay, so what is our answer so far? We have this answer, negative 4. We have this answer, which we couldn't do anything with, and we have this answer. So how do we write our answers? Of course, we're going to write everything that's in the square root stays in the square root. Everything that's on the outside of a square root, we put it in front of the square root. So our final answer will be negative 4 y to the 12th, the cube root of x squared. Negative 4 y to the 12th, the cube root of x squared. So I hope this makes sense. Let's move on to some questions that we will see on the practice quiz. Okay, so now let's actually do the cube root of negative 64. That's not 4i, that's actually negative 4. Remember, negative 4 times negative 4 is positive 16. Positive 16 times another negative 4 is negative 64. How about this next term right here? You can't do anything with that, so we're just going to save that and write it on our answer. And this guy over here, we're going to rewrite this as the power, actually, I'll do it in red since the cube root was written in red, the power of 1/3. A cube root is a power of 1/3. So what do we have left? We have a y to the 12th on the inside, and we know that a power to a power we multiply. 12 times 1/3 is 12/3. It's kind of like saying 12 divided by 3, which is 4. So I really have negative 4 with the y to the 4th, right? Because this answer is y to the 4th, with this at the very end, with that cube root at the very end. So our final answer is negative 4. We have the y to the 4th with the cube root of x squared, cube root of x squared at the very end. And if you're looking for that answer, you might think that it's this one, but it has a power of 3 right there, and we know that this guy is not the power of 3, it's the power of 4, so it almost is the right answer, but it's not. So in this case, none of these are correct, would be the correct answer. And here is another question on the practice quiz. This one's a little more fun. Now, you cannot separate the root here, the root there. You cannot separate the square root. Why not? Because you need to have pure multiplication between your terms in order for you to do that. And we don't have that, right? We have subtraction and addition. So what we're going to do is dig deep into our memory. In factoring, we're able to see a quadratic trinomial. The a value is 1, b value is negative 12, c value is 36, and we will be able to factor this quadratic trinomial, right? If I rewrite it and I start thinking what times what is c that if I combine together is b, I will notice that this is an actual perfect square quadratic trinomial, right? Because what times what is 36 that if you combine together is negative 12, that's going to be a negative 6 times negative 6. So when I set this up, the factored form with an x right here and an x right there, there's a minus 6 in here and a minus 6 right there, right? That's the only way that when you multiply you get positive 36, and when you combine them you get the negative 12. So in reality, this guy is these two binomials, the same identical binomial multiplied with itself. So what we're going to do is rewrite this as x minus 6 to the second power, okay? Now notice that there is a square root on the outside of the whole thing, so we have a square root on the outside of the whole thing. So all of that binomial x minus 6 to the second power is inside the square root. Now, what we're going to do here is rewrite it again as a rational exponent. We have the x minus 6 to the second power to the power of 1/2, right? The square root is the same thing as the power of 1/2. And a power to a power you multiply, so your final answer is x minus 6. And that's what you must type in on this question. Just type in the binomial x minus 6. Again, the square root and the square, they undo themselves, and all that's left is an x minus 6. I hope this helps.